Let x and y are two functions in terms of t, say function of t phi, and let there be psi t. X and y both are function of t, then x and y are said to be parametric functions. Now let us start with the question. Now from here if we want to find dy upon dx, तो क्या करेंगे हम? dy upon dt into dt by dx. dt will get cancelled and then we get the value of dy upon dx. So let us start with the questions now. Question number 1 is, find dy upon dx when x is a cos of t plus half of log of tan square t by 2 and y is equals to a sin t. Now log of tan square t by 2, we can write it as this, log of x power m, that is m log of x. So a cos of t 1 by 2 log tan t by 2. We can write it like this. Now differentiate, because it is function of t, so we will have to take differentiation with respect to t here. So derivative of x with respect to t, clear? Derivative of cos, derivative of log is 1 upon t, tan t by 2, derivative of tan is sec square t by 2, derivative of t by 2, that is 1 by 2. अगर इसको differentiate करें with respect to t, so what we get? dy upon dt, derivative of sine is cos of t. Now in the next step, a minus sin t, we can write tan as sine upon cos. So sin t by 2 cos t by 2. This 2 is in the denominator. Sec square is 1 upon cos square t by 2. 1 cos will get cancelled. So here we are left with 2 sin t by 2 cos t by 2. Now we have one formula. Sin 2 theta is 2 sin theta cos theta. Here the angle is half. So 2 sin theta by 2 cos theta by 2. So on the left hand side angle will also half. That is we get sin theta. So instead of 1 by 2 sin t by 2 cos t by 2, what we put? Sin t. So dx upon dt, a minus sin t plus 1 upon sin t. Now take the LCM. Minus sin square t plus 1. 1 minus sin square t, use the identity cos square t upon sin t. Now we want to find dy upon dx, that is equals to dy upon dt into dt by dx. Here we have dx by dt, so reverse it. What we get? Sin t upon a cos square t. Cos will get cancelled, a will get cancelled. Now sin upon cos, that is tan of t. Clear? Note it down. Now the next one is, if x is equals to a into theta minus sin theta, derivative of sine is cos. Differentiate this with respect to theta. Derivative of 1 is 0. Derivative of cos is minus sine. So here we get a sine theta. Now here we have 1 minus cos theta. Can we further simplify it? Now the formula for cos 2 theta is 2 cos square theta minus 1. Or we can write it as 2 cos square theta. Here we have 1 minus cos theta. So we will have to use the formula cos 2 theta is 1 minus 2 sine square theta. From here we get 1 minus cos 2 theta is equals to 2 sine square theta. When there is negative sign, then we have to use sine square theta wala formula. If there is positive, then 2 cos square theta minus 1. Now 1 minus cos theta, angle is half. So here we get 2 sine square theta by 2. Now sine 2 theta का formula हमारे पास क्या है? 2 sine theta cos theta. Now angle here is half. So we want to find value of sine theta, that is 2 sine theta by 2 cos theta by 2. Put these values here. 2a sine theta by 2 cos theta by 2 and a into 2 sine square theta by 2. Now we want to find the value of dy upon dx. So dy upon dx is equals to dy upon d theta into d theta by dx. dy upon d theta is 2a sine theta by 2 cos theta by 2 into d theta by dx, reverse the term, 2a sine square theta by 2. 2a will get cancelled, 1 sine will get cancelled, cos upon sine, that is cot of theta by 2. Now the next one. If x is equals to a sec cube theta, y is equals to a tan cube theta, find dy upon dx at theta is equals to pi by 3. Now x is function of theta. So differentiate x and y with respect to theta. What we get? Dx by d theta a. Sec cube theta, derivative of this is 3 sec square theta. After that, derivative of sec theta. Derivative of sec theta is sec theta tan theta. Now dy upon d theta. A tan cube 3 tan square theta. Now derivative of tan, that is sec square theta. Clear? Now here we get 3a sec cube theta tan theta. Now dy upon dx. Dy upon d theta into d theta by dx. Dy upon d theta 3a tan square theta sec square theta into d theta by dx. Reverse this term. 1 upon 3a sec cube and tan. 3a will get cancelled. 1 tan will get cancelled and sec square will get cancelled. So here we have left with tan theta upon sec theta. We can write tan as sine upon cos and sec as 1 upon cos. Clear? So we are left with sine of dx at theta is equals to pi by 3. So instead of theta, we will put the value as pi by 3. Sin pi by 3 is root 3 by 2. Next is find dy upon dx if x is equals to a cos cube t and y is equals to a sin cube t. Now function is with respect to t, so take the differentiation with respect to t here. So dx upon dt, a 3 cos square t, derivative of cos minus sin t. Now dy upon dt, a 3 sin square t, derivative of sin is cos. Now dy upon dx is equals to dy upon dt into dt by dx. Dy upon dt 3a sin square t cos of t into dt by dx, reverse the term, 1 upon minus 3a sin t cos square t. 3a will get cancelled, 1 sin and 1 cos. So we are left with minus sin t upon cos t, that is minus tan of t. Now next one is if x is equals to square root of a power sin inverse t, y is equals to square root of a power cos inverse t, then show that dy upon dx is equals to minus y upon x. Now we can write this as a sin inverse t power 1 by 2. Clear? We can write this term as this. Now this is, apply the formula here. Let it be x power 1 by 2. Differentiate with respect to t. Dx by dt 1 by 2 a sin inverse t x power n and x power n minus 1 1 by 2 minus 1 minus 1 by 2. Now differentiation of which term? A sin inverse t, derivative of a power x. Derivative of a power x is a power x log of a. Instead of x, here we have sin inverse t. So take the derivative of sin inverse t. So what we get? 1 upon 2 square root of a sin inverse t. A sin inverse t log of a, derivative of sin inverse 1 upon square root of 1 minus t square. Clear? Now differentiate y with respect to t. 1 by 2 a cos inverse t, 1 by 2 minus 1 minus half. After that derivative of a cos inverse t, derivative of a power x. A power x log of a. After that derivative of cos inverse t. 1 upon 2 square root of A cos inverse T, A cos inverse T log of A. Derivative of cos inverse is minus 1 upon square root of 1 minus T square. Now we want to find dy upon dx. So dy upon dt, A upon root A. A upon root A, if we rationalize it, so we are left with square root of A. So we can write this as square root of A cos inverse T. Log of A minus upon 1 minus T square. Dy upon dt into dt by dx. Reverse this term. It will become square root of A sin inverse T. 2 will go up. Square root of A sin inverse T. Log A reverse करेंगे तो it will come in the denominator and root 1 minus T square will go in the numerator. Clear? This will get cancelled. So here we have left with dy upon dx is equals to minus square root of A power cos inverse T upon square root of A sin inverse T. A cos inverse T is the value of y and this is x. So dy upon dx is equals to minus y upon x. Now the next one. Write down the statement. If x is equals to sine inverse 2t upon 1 plus t square and y is equals to tan inverse 2t upon 1 minus t square, t is greater than 1, prove that dy upon dx is equals to minus 1. Let t is equals to tan of theta. Sine inverse 2 tan theta 1 plus tan square theta. This is the formula for sine 2 theta. So we can write it as this. Now it is given that t is greater than 1. It means tan theta is greater than 1. Tan pi by 4 is 1. And value of tan lies between minus 1 to infinity. So we can write it as pi by 4 is less than theta, tan pi by 2 is infinity. So pi by 4 less than theta less than pi by 2. Here the angle is 2 theta. So multiply this by 2. We get pi by 2 less than 2 theta less than pi. It means value of 2 theta is less than pi. Value of 2 theta is less than pi. So instead of sine 2 theta, we write it as sine pi minus 2 theta. Sine pi minus theta. यहाँ पे कौन सा क्वाड्रेंट, सेकेंड क्वाड्रेंट में साइन इज पॉजिटिव. So we can write it as sine pi minus 2 theta. So we get pi minus 2 theta. Theta is t is tan theta. So theta is tan inverse of t. Now differentiate with respect to t. Differentiate with respect to upon dt. Pi, derivative of pi is 0. Tan inverse t is 1 upon 1 plus x square. So we get dx by dt minus 2 upon 1 plus x square. Now here put t as tan theta, 2 tan theta, 1 minus tan square theta. So this is the formula for tan 2 theta. Tan 2 theta. Now 2 theta is less than pi, so we will write it as tan inverse tan pi minus 2 theta. But tan pi minus 2 theta, tan is negative here. But here we have this positive term, so take negative outside. Because tan inverse pi minus 2 theta is minus tan theta, so minus minus will plus. So we get minus pi minus 2 theta. Now differentiate with respect to theta. First put the value of theta, minus pi plus 2. Theta is tan inverse t. Now differentiate with respect to t. dy upon dt, derivative of pi is 0. Tan inverse is 1 upon 1 plus x square. Now we want to find dy upon dx. dy upon dt into dt by dx. Reverse the term. 1 plus x square upon minus 2. So we get dy upon dx as minus 1. Note it down.